Hello, my name is Kate Sanborn, and this video is about my CAT Vehicle REU experience. I am a rising junior studying computer science and computer engineering at the University of Alabama. I was excited to participate in the CAT Vehicle REU program this summer with the University of Arizona. I was hoping to learn more about autonomous vehicles, research, and what it's like to be a graduate student. The program was conducted virtually this summer, so I completed my project from my home in Franklin, Tennessee. For my project, I worked with my partner Alex and our mentor Sanborn.
We were given dash camera footage and CAN bus sensor data recorded from previous drives. In the CAN bus data, there were several recorded signals, like velocity, steering angle, and the distance of the car in front of us. Our job was to synchronize the video with this data. Once we had accomplished this, the goal was to identify meaningful events from the CAN bus data and output the corresponding clips. Some of these included when our car turned, when another car passed us, or when there was a car in front of us while cruise control was active. In the future, other researchers will be able to use these clips to train models to recognize when these events are occurring. My main job was to identify several of these events after Alex had synchronized the videos and sensor data. The first step of this was choosing which signals to use to identify the event. There were several to consider, and it involved a lot of thought and experimentation to decide which signals would be useful and how they should be used. Once I had an idea of which signals to use, I had to determine the conditions each signal must meet to indicate that the desired event had occurred. For instance, with identifying when the car was braking hard, one signal I looked at was the longitudinal acceleration. I had to decide what range of accelerations would count as a hard brake and how long the acceleration needed to be in that range. After I had a basic script, I would input the sensor data and corresponding video and evaluate the output clips. Usually, I had identified a few of the events I needed, but some of the output clips would be incorrect and should not have been included. Also, when I watched the whole video, I might notice an event that my script had missed. I would continue adding more signals or adjusting my conditions as needed, testing each time to see whether I was getting closer to identifying everything correctly. Once I had my script working on 2 or 3 videos, I moved it to a Docker container with parallel processing. This allowed me to test my program on more videos faster. I would continue to evaluate and adjust my code until I was satisfied with the output. In the last few weeks of the program, we received a lot more data from many new drives. It was too much for me to run on my personal machine, so I transitioned to testing my code on the high-performance computer. With the HPC, I had much faster run times. In the end, we had processed hours of data and produced several clips for each event. For instance, using the synchronized videos and one of our scripts, we were able to identify this clip of a passing car. In the future, others can use these clips to train machine learning models to recognize these driving events. As research and development of autonomous vehicles continues, it will be important to have a data set like this.
With this REU, I had the chance to learn many new things. The experience helped me grow as a student and a researcher. I enjoy working on a coding project with a team and watching the pieces come together from start to finish. Overall, it was an excellent experience, and I'm thankful that I got to participate in this program this summer.